So at the top of your notes, you're going to write characteristics of polynomials. And the characteristics part is us coming back to what we've done repeatedly for every single unit, right? So what are characteristics? What do we find typically about graphs? Domain and range. X-intercepts, Y-intercepts. And behavior. Max, min. We've done locator point, but we're not going to do that this time. Increasing, decreasing. We've done transformations, but we're not going to do that this time. So this is just looking at graphs, finding the specific things that describe the graph, just like we've done before. It will be a little bit different because polynomials are not like parent functions. They're not like, oh, it's a quadratic, but then some stuff has happened. It's like, no, they're just like curves, just like lots of up and down curves. All right, so the polynomial we're going to look at is y equals negative x to the fourth minus 2x to the third plus 2x squared plus 3x minus 1. So that was negative x to the fourth minus 2x to the third plus 2x squared plus 3x minus 1. And we're going to go ahead and graph that on our calculator. And when I graph it, it's a little bit small on the screen, and so I'm just going to change the window so it's a little bit easier to see everything. So on your window, if you do, instead of 10 to the left and 10 to the right and 10 down and 10 up, if you change those all to 5, it will have an effect of kind of zooming in on the graph, but still being kind of square-shaped. So there it looks like we're zooming in. Okay, so I'm going to kind of try to draw a sketch of this for my notes. All right, what do you guys want to look for first? This is a beautiful awkward silence we're having. What could we look for? What do we know how to find with the calculator? X-intercepts, yeah. How many X-intercepts do we have? 4. Okay, so we've got 1, 2, 3, 4 X-intercepts. So I think that especially in a problem like this where you have a bunch of X-intercepts, I think it's a little bit easier to hit your Y equals button and graph 0 for Y2, because then we don't have to do left bound, right bound a bunch of different times. Then we can do the intersection version of finding the X-intercept, and I think that's a little bit easier. So we're graphing Y equals 0. I'm going to hit the graph button. If you have a color calculator, you saw it graph. If you don't have a color calculator, it just looks like it took time to do nothing. So now we're going to do second trace, option number 5. And I'm going to go from the left because I feel like reading from left to right is an American thing. Makes me feel comfortable. So I'm going closest to the left one, and then I'm just going to press enter, enter, enter. You don't have to be on top of it to find it. You just have to be close to it. So I got near it, and then I pressed enter, enter, enter. And I'm going to go ahead and do 3 decimal places. So -2.194 I round? There's my first x-intercept. And then I'm going to do second trace number 5 again. And I'm going to move it so it's a little bit closer to the next one. It doesn't have to be right on top of it. It just has to be near it. And then I'm going to press enter, enter, enter. And then I'll move to the next one. Enter, enter, enter. And then the last one. All right, so next we have a Y-intercept to find. Does anyone remember how to do the Y-intercept? You can look at the table. So second graph, where on the table are we looking? Where x is 0. So x is 0 when the y coordinate is -1. So you can look at the table when x is 0. Your other option is you could have done second trace. Number 1 allows you to plug in the x value that you want. And you can plug in an x value of 0, and that'll give you that y-intercept of -1. So 2 different ways of finding that point. Okay, so x-intercept, y-intercept. What else do we typically like to find? Say it again. Domain and range. Okay, so domain is how far left you go, how far right you go. Are there any values skipped in between? What do you guys notice about the x values? All real numbers. We go left forever, we go right forever. Okay. What do you guys notice about the range? Negative infinity for sure. It goes down forever. What about up? It stops at something, right? I'm not sure what it stops at, but it's, yeah, something up here. Okay, so I don't know what that is yet, so I'm going to leave that there to fill in a second. Okay, what else do we find? Max and min. How many maxes are there? 2. We have a max right here and a max right here. Nope, I wrote min, but I meant to write max. 2 maxes. Do we have any mins? Yes. Yeah, we got 1 min right in here. Okay. All right, so to do the max, I do second trace number, to do the max? 4, second trace number 4. And when it says left bound and right bound, what I need to do for left bound is I need the cursor to be on the left side of the mountaintop. So if my mountaintop is up here, make sure your cursor is to the left of it and press enter. Now it says right bound, so I'm going to move my cursor to the right side of the mountaintop and press enter. The guess is always stupid, so I'm going to press enter one more time. And then it will tell me the actual max. So -1.823. All right, and then I want you guys to go ahead and find the other one. So second trace number 4, you're going to have to do left bound, which will be the left side of the mountaintop. Right bound will be the right side of the mountaintop. So left side. Right side. Got an answer, but I'm hiding it from you. What was the other maximum? Oh. And then what's the y coordinate? Okay. And then we have a min. So for the min, we're going to do second trace number 3 this time. And for the left bound, we're going to go to the left side of the valley. And for the right bound, we're going to go to the right side of the valley. I'm hiding my answer from you. So my calculator says negative 4.9999999. Anyone have something that says different? Everyone says that? I think first period some people had their calculator said negative 5.00000000000. So what is my calculator trying to say? It's trying to say negative 0.5. Okay. And then what should we put for the y coordinate? 813. Okay. Do we have enough information to finish the range now? Yeah, so we know the graph goes down forever, down to negative infinity. How far up does it go? What's the highest point that it goes up? 1.25. So we use that y coordinate from the max, and it's the same for both of them. But if one of them had been higher, we would have just used the higher one. Is that a parenthesis or a bracket? Bracket, it's a point, you really equal it. Okay, what else do we need to find? Increasing and decreasing, my favorite. Is it your favorite? No? Yeah? No? No? Okay. So I'm just going to draw a little sketch so I can draw my stick figure dude and write my numbers in and all that stuff. So what is the guy doing first? He is increasing, he's walking uphill, he hits the top of the hill, and does what? Slides down. What number was the top of the hill? It wasn't 1.25. Negative 1.823. We always use the x coordinates because the x coordinates describe where. So we want to describe not what was the height. The 1.25 is the height. We want to describe where was that height happening. Does that make sense? Okay, so x values. I really need to make that one of the dead animals. And if we accidentally use y values, we kill something. But I haven't made it an animal yet, so you guys are safe for now. All right, it decreases down here. What's the x value right there? Negative 0.5, yep. Then what happens? Increases again to what value? 0.823, and then decreases. And what's the x value right here? Is it an infinity or a negative infinity? It's an infinity because it's a right arrow. You were thinking negative because it goes down, but that's the y value of the arrow. The x value of the arrow is that it goes to the right. So this is a right arrow, this is a left arrow, so positive infinity, negative infinity. So what is the first answer for increasing? Okay. What is the second answer for increasing? Yeah. And what do we put in between? U. Okay. What's our first decreasing answer? Okay, and then what's our second one? Okay, I'm going to put the U in between. What else do we need to find? End behavior. Okay, so we've got as x goes to the left, so as we look at the left arrow, and as we look at the right arrow, and what do we notice about both arrows, the left arrow and the right arrow? They both go down. So y goes to negative infinity, y goes to negative infinity. Arrow goes down, arrow goes down. Okay, one last thing. It starts with a C. Yeah, continuity. So if you were to trace this graph with your finger, would you pick your finger up? No. So this graph is continuous. There's no gap. There's no asymptote. There's no jump. There's nothing weird about it. You just trace it with your finger. It's a nice curvy line. Okay. So those are all the things that we have found in the past, and those are the things we're going to find again. We just have more decimal answers now than we've had before. That's all that's changed, really. How are your brains? Good. So I have something for us to practice for the next 30 minutes. You are not going to do it as homework. What's homework? The packet we had before that we put in our bags. Okay, so we know what homework is. We're going to work on this assignment till the end of the period, and then whatever we don't finish is probably going to be our warm-up on Monday. Yes? What if there's an imaginary number? If there's imaginary numbers, then we do not find it to describe the graph, because when we're describing the graph, we're describing what is actually there instead of what you could work with without. So the purpose of the imaginary number stuff is so that when we are solving something by hand, we don't get stuck when we see it. We can actually keep working with it. That's kind of the beauty of imaginary numbers. But as far as looking at things that are actually there, we ignore imaginary numbers because we're looking at a graph of real things. Does that make sense? So they do have what they call an imaginary number plane where you can graph imaginary numbers, but we don't do that. And I've taken a lot of math and I've never done that. So I don't know if at some point they thought it was important and now they don't really, or if for some classes you learn it because you need it for something. I don't know, but I've never done it before. So, all right. Okay, so let's, I think finding intercepts is going to be really easy for you guys. I'm not too worried about that. Let's go ahead and hop down to find domain and range, because it takes more than meets the eye, I guess, to do the problems. So I'm going to do number 11, x to the 4th minus 3x to the 2nd plus 3x plus 3. And now that we're drawing other graphs, if you feel like you're too, like this one, we could probably leave the window the same and be okay, but if it feels like we're a little bit too zoomed in because I'm not quite sure what's happening up here at the top of the screen, you can just hit the window button and make it -10 again. -10 and 10 and -10 and 10. This size screen should work for the majority of the problems on the worksheet. Some of them, you might want to change it to 5 so you can get a closer look, but this should be good for most of them. So if we look at this picture, what do we notice about the domain of the graph? How far left, how far right? All real numbers, yeah. In fact, if we think about all the stuff that we've done with polynomials so far, they've always gone left and right forever. You notice that, right? There's some like weird loops, or not loops, but there's like curves in the middle. But on the left side and the right side, they've always had an arrow. All right, for range, what do we notice about range? Yeah. Does it go down forever? No, but it does go up forever. So what do we know that we can already write? We know it can be to infinity on the right side. Okay, we have to find the number. How do we find how far down it goes? Find the max or the min. In this case, we're going to look for the min because we're looking for the lowest value. You had the right idea. Last time it was the max. That's good. So we're going to look for the min. So I'm going to do the left side of the valley and the right side of the valley. And when I find the minimum, am I using the x-coordinate or the y-coordinate to describe the range? The y-coordinate. So -3 2.243. Did not leave enough room. Bracket or parenthesis? Bracket. Okay. Now, I would argue we can do the domain and range of number 13 without even graphing it. Anyone know how? Yeah.
Because you can see that it has a negative coefficient and an odd degree. Whenever something has an odd degree, you know that the domain and range are all going to be negative.
Yeah. So when we were sketching these by hand, you guys remember, right? When we were sketching these by hand, we saw, oh, if it has a degree of 5, the arrows go opposite directions, right? One goes up, one goes down. So if an arrow goes up and an arrow goes down, what does that mean about your range? All real numbers. And we know that the domain for these is always going to be left and right forever because we've drawn a bunch of them and that's what it's been every time. Okay, so this one, without even graphing it, just from what we learned about doing it by hand, I already know that the range is down forever, up forever, because it was a degree of 5, and that number is odd, and so the arrows go opposite ways, up and down. We can do the same thing for 14. Can we do the same thing for 12? No, why not for 12? It's even. The degree is 4. That means that either both arrows go up or both arrows go down. But that means we're going to have a number for one of ours because it doesn't go up and down forever. It goes just one direction forever. Okay. All right. So work on that. Do you have to finish this for homework? No. You just work on it. Just however far we can get in 20 minutes. I'd say maybe the front side of the page. Definitely not the back. But I think we can probably get a lot of the front side done. Yeah.